The following is the video solution from JSDT Solutions. Question 3 says, given f of x is equal to the square root of x over a, where x is less than or equal to 0, the point P, which is negative 8 and 2, lies on the graph of f. Determine the value of a. Okay, so let's take this point and substitute it into this equation. So if we have the square root of x over a, and P is a point that lies on this graph. So the x value is negative 8 and the y value is 2. So 2 is equal to, and we'll say in the square root of negative 8 over a. So to solve for a, we can just square both hand sides to get rid of the square root. And now we have 4 is equal to, and that breaks open when we have negative 8 over a. Okay, you can just cross multiply or transpose the 8, but if you cross multiply, just put this over 1. 4 times a is 4a, and 1 times 8 is negative 8. If you divide both hand sides of the equation by 4, a is simply equal to negative 2, and that is our answer. Moving on to the next question. Okay, question 3.2 says, determine the inverse of graph f. So to find the inverse, we first need the equation of f, and we'll just fill in the value of a. So we can call this y is equal to, and we have the square root of x over negative 2. Okay, so x over negative 2, and then we need to swap x and y to find the inverse. So in place of y, say x is equal to the square root of, in place of x, say y, and then over negative 2. Okay, so now you have to make y the subject. So to get y on its own, you see that something that is stopping us right now is the square root. So we need to get rid of it, and we can do so by squaring both hand sides of the equation. So now we have x squared is equal to, and this is y over negative 2. To make y the subject, we can multiply both hand sides of the equation by negative 2, and therefore y is equal to, this is just going to be negative 2 x squared. Of course, we can tell them the domain, and we could have also just set the constraints all through here, but they didn't really specify that we needed to. So we can just tell them the values of x for which this graph will exist, because the original graph, okay, this was restricted. So the original graph's domain was x is less than or equal to 0. So let's think about what this one is going to look like. This graph, it's the inverse of a parabola, really, okay? But we're looking at that as the original. So this is what it looks like, and it's restricted right there at 0. So it's that graph that is at the origin. It has a turning point at the origin. We can see that the parabola would be concave down. So it's concave down and it looks like this. But we need to see which one would exist. If it is concave down like this, okay, this is the inverse. I have to actually call it the inverse. This is the inverse. And then the graph of f, that was this graph, okay? Technically, the inverse of a parabola, okay? What that one would look like depends on what this one looks like. So if this one is concave down, okay, towards the negative part of the y-axis, this one, the inverse, will also be concave down, but towards the negative part of the x-axis. So it ends up looking like this, okay? It ends up looking like that. Now, what they told us was that the values of x for which this exists was where x was less than or equal to 0. But here is the thing. You see, with these graphs, you need to understand the relationship between the original and the inverse. Okay, so we can look at the domain and the range. So in the original graph, we were told that x is less than or equal to 0, right? Now we know that the range of the original, we know what that is. And the reason why we would know is because they told us that there was a point called negative 8 and 2. Negative 8 and 2 lies on this blue graph, right? This is our original graph. If negative 8 and 2 lies on this, let's see where that will be. Negative 8 on the x-axis, so we'll go 8 units to the left, and 2 going up. So that means the part of the graph that exists, if this is negative 8 and 2, would be this section, okay? This part is the one that was cut off. So if this is the part of the graph that exists, okay, then this restriction will affect this inverse, okay? So we can clearly see here that the range of the original is where y is greater than or equal to 0. You see that this will only have values of y that are either equal to 0 or values greater than 0. That's where we have y values here. Okay, so we can say this is where y is greater than or equal to 0. And then this is how we find the domain of this. The relationship between the original and the inverse graph works like this. You see, the same way x and y swap is the same way the domain and the range will also swap. So if the original's domain was x is less than or equal to 0, the inverse's range will be y is less than or equal to 0. And then if the original's range was y is greater than or equal to 0, this will make the inverse's domain x is greater than or equal to 0. This is something that you need to always keep in mind with the inverse function and the original. So all this means is that this is where this graph exists, specifically where x is greater than or equal to 0. And this is our answer. Remember, this will be much faster for you to think about in your head than actually, writing it out and explaining it. Okay, moving on to the next question. Question 3.3 says, sketch both the graphs of f and the inverse on the same set of axes and show at least one point and the intercepts for each graph. We already have a rough idea of what it's going to look like, but let's put down our Cartesian plane first. Okay, and you see that where you get that rough idea is when you start to consider what that domain is, okay? Because you see that the original had a domain, so you need to also state that for the inverse. So we know now that the original graph looks like this because they told us about a point that lies on the graph. Okay, so -8 and 2. So the original graph looks like this. Okay, concave down parabola like that, but only half of it, of course. And we have that point, so we can just put that point over there. That was P, and we know that that was -8 and 2. So now we know that the inverse would look like this. Okay, so you see that whole story with drawing the parabola like that, and then we knew that, okay, this one is also concave down. Okay, but of course I started with this one. So we know now what this one looks like, but you now need to decide on which wing would stay. Is it this wing over here or this wing? You're going to see that by looking at this information, the relationship between the domain and range of your original and your inverse graph. If this is what we have, right? And we know that this is the inverse. Yes, I know it's a parabola, but remember it is still the inverse because they told us the original was this graph. Okay, so let's look at the information about the inverse. We know that its domain is x is greater than or equal to 0. And that already tells us everything. Okay, the range was y is less than or equal to 0. Do you see that where the y values of this graph are less than or equal to 0 is all through here? It only has negative y values. See, look at that. It's a negative y value, negative, all through. But we also found out that x is greater than or equal to 0, meaning if you look at this side, look at the values of x that this exists for. These would be values of x that are equal to 0, but less than 0 as well, okay? Equal to or less than 0, or less than or equal to 0. But we can't take that because we know our domain of the inverse is x is greater than or equal to 0. So this is the part that would stay, and that's what we would draw. Okay, so we're simply just drawing our parabola like that. Make sure it touches that origin. And so there we go. And now we have a point, right, on both graphs at the origin because you saw how it was restricted from the origin. So both their turning points was at 0. So we can say that's 0 and 0. And now we can also just draw this point, okay, and what it would look like on the inverse. So this is the original graph f. This is the inverse. And this point wouldn't be -8 and 2. It would be 2 and -8. So we can just put that down and say this is, I'll call it P prime. This is 2 and -8. And that is what our graphs would look like. Okay, there we go. We show them the x-intercept, which is also a turning point. And we've shown another point using this point that they already told us. Moving on to the next question. Question 3.4 says, if P is reflected, if P is reflected in the line y equals -2, Determine the coordinates of P prime, the image of P. Okay, I'm just going to change that. Let's call it something else. Or let's just not call it anything. Let's just put it as P. And this is the other point on that graph. So P prime. You don't need the graph for this. Okay, it may seem like you need the graph because these are points that are on F, but you actually don't need the graph for this. Think about it like this. P is that point, -8 and 2, right? Let's say P was here. Let's just mark it in red. If this is P, -8 and 2, and they're telling us that this point, it's just a point that is reflected across this line y equals -2. Well, what does that line y equals -2 look like? It's y equals, meaning it's passing a particular y value. It's passing -2 on the y-axis, and then its equation is y equals -2. So if a point is being reflected across a line, it really just means that, see, this point is here, P. It's going to appear over here. But we can't just say, oh, it appears here and then just guess where it is. Here is how reflections work. And for that, we need to know what this y value is. P's y value is specifically 2. When you reflect a point across a line, what it means is that if you travel from that point to the line that it was reflected across, the new point that was reflected is going to be at the exact same distance as from the line it was reflected from to this new point. So their distance will be exactly the same, and that's how you would know this was reflected across this line. So the distance between this line y equals -2 and this point P is what? That distance is, this is -2, this is 2. The distance there is 4. You can say 2 minus -2. But you can also see it as I went 1 unit up to get to 0, and then 1 unit and 1 unit to get to 2. So that's 4, right? 4 units. So the distance from this line to this new point will also be 4 units. If we know that this is a reflection, okay, it's going to be vertically in line with this reflected point. So P prime, its x value is also -8. And what is its y value now? Well, it's going from this point with a y value of -2, and it's going exactly 4 units down. Okay, that distance is still 4. So what is -2 minus 4? That is -6, and that is our point. P prime is simply -8 and -6, and that is our answer, and that is it for question 3.